Hello and welcome everyone. Today we will have the session on 5G session establishment signaling analysis. Before I start this lecture, actually I just want to thank you all for your comments and feedback on my last video on registration analysis and uh, and I got really the motivation to do this 5G session establishment session after that because I was very busy in my own work, and I have been on traveling, so I could not get the time to record this session. So now I'm here, and I hope that it will be like this, and I'll be also uploading some more sessions after this video with respect to security and roaming also within the 5G network. Okay, so let us start. So in this session establishment 5G, what we'll be going to cover is basically we will describe you the functions of a PDU session establishment procedure, how it is different from 4G, what is the call flow, what are the triggering conditions of a PDU session, and then we will analyze basically all the messages flow that is being exchanged across different network elements of 5G. So if you see this thing, for example, if you let's say compare 4G and 5G session management comparison, you can have this. So within the 4G context, we say that the PDN connection establishment, whereas an 5G we call as a PDU session establishment, which is actually creating a default bearer, or in terms of 5G, the QoS flow established, we say that. So basically in the 4G, it's a dedicated bearer thing in which the bearer can be updated and deactivated. But when it comes to 5G, it is the PDU session update, which is, for example, when you say that the 5G session establishment has been done, so which means that the 5G network has a QoS flow added, modified, or deleted through a PDU session update procedure on a session basis. So it is basically not create a dedicated bearer for the user. It will just create a QoS flow, and which can be modified or deleted as per the requirement, unlike a 4G network which has a bearer activated, updated, or deactivated. And then it when it comes to PDN disconnection, and as compared to PDU session release, all bearers or the QoS flow, quality of service flow, are released. But there is one extra thing which is happening on 5G, which is the selection or selective activation deactivation on of the user plane connection for an existing PDU session. So what happens when it comes to activation? To activate a PDU session through the service request procedure, only user plane connection needs to be established. As the control plane was not released during deactivation. This is the new concept they actually bring in the 5G network, that in the control plane, they don't disconnect the control plane session. So the control plane is already is always established, and only the user plane traffic can be, let's say, activated or deactivated. So to activate and to deactivate a PDU session, its user plane connection is deleted, but the control plane connection is maintained. So this is how you can actually you don't have to do the again establishment of the control plane session, because you can save a lot of resources that was not been happening in the 4G thing, because in the 4G you need to again establish the control plane connection, which is not there in this 5G case. These new procedures help save radio resources and facilitate quick recovery of PDO session. So this is what you can think of as like comparing 4G and 5G session management things. Now, if you think from what is the function of a session establishing procedure, what we are trying to do, actually this is also the concept that you need to take. Basically in every PDU session or PDN session, what you are doing essentially is to give uh, an IP address to the UE, to so that the UE can go to the internet. This is what you want, what you are doing in the session establishment procedure. So you basically allocates an IP address. I mean, the network allocates an IP address to the UE and establishes a dedicated channel to the DN, to the data network, which is going to the internet. This way, the UE can use IP address to access services on the data network, for example, uplink and downlink services. The second thing, the AMF selects a slice instance for the PDU session and select the SMF that supports the slice instance. So in the 5G network, we have introduced something called network slicing. So for every session, there can be a default slice, or there can be a dedicated or a separate slice, depends upon the configuration. So basically, along or in addition to the IP address allocation to the UE and the establishment a dedicated channel to the DN, you're also giving an IP address to the UE, and as well as the network elements in the 5G network. For example, AMF, the access mobility function, is also selecting the slicing instance that for this IP assignment and this dedicated channel path that I'm creating to the DN, what slice I need to keep it, and what network elements supporting that slice would be kept for that particular session. So this is what we are doing. The AMF selects SMF, and the SMF then selects the PCF and UPF that supports the slice instance. So this is what are the functions of a session establishment procedure. So, and what are the triggering conditions? In what scenarios we can do a session management thing once the UE initiates a PDO session? And the second thing, when there is a handover from EPS to 5Gs, then the handover will trigger. And or there is, for example, a switch between from 3GBP to a non 3GBP network, then also a PDO session. The UE initiates the session establishment procedure, which is to create a user plane to go to the internet with an IP which has been allocated by the network, and also to get the slice, that which slice is supported. Then, for example, a network also triggers a PDU session procedure in which thing that, for example, if there's an application which is sending the request to network exposure function, let's say a third-party application, in which there is also you need to have a entitlement server or a relevant also application install on the UE which can receive the request and can triggers the UE to generate the PDU session thing. So this is what also can trigger. An application function sends a short message to the UE. Based on this message, an app on the UE triggers a PDU session establishment procedure. So these are the all triggers of a session establishment procedure. So here is the example of in what cases the application is triggering basically. So if you see that there is an AF application function which is sending the request to network exposure function, which is the entity in the 5G, then it is getting the authorization or getting the relevant profile from UDM, which is in the form of SDM get response and request message. Then the ECM ECM and SDM procedure that we have studied initially in the registration management or the registration analysis, in which the NEF needs to get the profile from the UDM of that request or of that particular MZ, that what is being configured, what is being allowed. When it received, then it submits a trigger to the SMSC SC function, which is then start the empty flow for the UE, same as the CS network, or that what we know in the CS and the LT network. So in this way, you can see that you have to have an application also or an software which can identify that which request is coming for the UE, and it has to establish the status a session management procedure. So this is a small a call flow that in what cases the network can trigger the UE to do the session management thing. Okay, now let us take a look on the UE requested PDU establishment thing. When I say non-roaming, on roaming, the both procedures is the same with local breakout. So with local breakout, it means that you are going to the internet, you are going to the DN from your own network. You're not going, for example, in case of roaming, even when you are visiting a partner PLMN, but always you will go to the internet from your network. So in this case also, or if it's non-roaming also, it will choose the home network to go to the internet. Okay, so now let us take a look briefly on this session establishment call flow. Then we will look at the parameters. So basically, before PDU session establishment request sends to AMF, you need to think like how the UE knows that which AMF he needs to talk to. He needs to have a GUTI, okay, which also means that the initial registration procedure of the UE authentication registration is already been completed. So, and the AMF has been notified by all the relevant profiles that which SMF he needs to select to, which slicing instance the UE supports, the UE context, everything is downloaded in the AMF. So if there is this video session establishment request, the prerequisite, if I would like to, if I you can have the numbering. For example, the first point is that there is a SUSI deconcealment process that happens uh, uh, for the registration procedure, that and when the request of SUSI comes to the UDM, the UDM deconceal the SUSI into SUPI, and then there generates the 5G AK vectors back to the AMF, and then AMF start the security mode complete procedure that we already studied. But just to give you the context, AMF has to have the relevant information of the UE, which is the context of the UE. Based on that context, it has to have all vectors or the keys associated for RRC signaling, for NAS signaling, and how and what are the URIs that is being configured on the UDM. So it has to have everything. Now, when the request will comes to the AMF selects the SMF based on, it can be based on the DNN, it can be based on, for example, it can go to the NRF to select me the SMF, or it can maybe check from the slicing instance which SMF support this particular slice. So it depends basically on the configuration that how you have configured on your network. But basically it is preferred that if you're having more than one SMF, then you can go through the NRF to select the SMF thing, and all the NFP profile should be downloaded in that NRF. Okay. Now, when the request goes to SMF, then the SMF needs to know that what is the subscription retrieval, and he has to take the profile from the UDM, check the information, so it will, or subscription for updates, everything it has to send to the UDM. Then after getting it back, it will send the response back to the AMF that okay, this is I'll be ready to establish the session, this is the profile of the user, this is the policy and everything. Then the authorization take place over here, which is the secondary authentication procedure, which is also introduced in 5G. So you are having not only integrity and confidentially protected initially in your registration, but once you are doing the session establishment procedure, like the PDO session, then also you will have to authenticate yourself to the network, that based on the UE policy and based on the SFF policy that it will download from the UDM, the UE has to authenticate itself. Now, once the authentication has been done, the secondary authentication has been done, now it comes to for the SMF to download the PCF profile of the user. So the SMF will send the SM policy association establishment, then it will receive download that what is the dynamic rules, everything is configured. If it's a PCC dynamic rule or the static rule, what sort of the GBR the GBR or the non-GBR values, what are the QoS or the QCI values that has been configured for the user, the SMF will get that thing. Once it's done this, then the UPF selection will take place. For the SMF, it has to establish the GTP-C channel or the GTP-C tunnel, I would say, with the UPF for the control plane GTP session, that, and it also will see from its public pool of IPs that or the tau TAC area which the user is go to, that this SMF has to select this UPF. So it can be based on different criteria, based on the slicing type, based on the DNN, based on the IPs, based on, for example, which area has been selected to, what is the SSC mode. Also, it can check that which UPF it needs to select to. So this is basically the N4 interface which which the SMF connects the UPF to, which is being carried through the PC or PFCP protocol, I think. Yeah. Now the SMF, yeah, this is the same thing, and then the SMF will establish the SMF will establish the N4 interface with the UPF with the modification procedure, and tells UPF if it's having a static IP, it will tell UPF to allocate this IP to the user, or it will ask that if the UPF is configuring any IP, so it will tell the to SMF that this is what the IP is configured or should be allocated to the user, and then once the SMF will get the IP, it will send the N1 N2 message transfer to the AMF to send to the user or to send to the UE. So once it will send this N1 N2 message transfer, then what happens, it will get the response back, then the AMF will start the NAS signaling to deliver the IP address and the relevant profile to the user. Okay, then it will N2 in this N2 message, it will send to RAN, and the RAN will respectively send to the UE, and it will receive the ACK, and then the UE having the IP and the profile, that what is the SSC mode supported, what is the DNN support, everything what is being done. So now it will now send the first uplink data to the UPF to go to the internet. If it's IPv4, then it's only, for example, one uplink and downlink procedure. Here first uplink data, and then it will send this downlink data also over here. And then if it's, for example, the SM context response, and this value is basically that, if it's any parameters that is being configured or being received on the AMF from UE, then it will also update SMF that, okay, this is the context, okay, response value is being changed, or how it's being generated. So basically this is briefly the high level information on the call flow of the session establishment procedure. Now let us look on the parameter level details for the PDU session. If you just give me just 1 minute break, I'll just have one drink of water. Okay. Now, what are the key parameters for PDU session establishment? Let us start. So there are different elements, or different in the call flow. We can see there can be different stages in which you need to have an understanding about which parameters are being exchanged across the network. This PDU session establishment requires the SMF selection, the SM context request, the SDM ECM registration, the PDU session authorization. So all basically what we have discussed in this call flow, we're going to have a look on the parameter level details, that what is going across each element. Okay, so this is basically the Uplink NAS Transport, which is coming from the UE towards the AMF. It has to have a payload container type, the PDU Session ID, request type, SNSSAI, which is the slicing type, that which slicing type is supported, and the DNN, which is the APN of the network, domain network name, which can be anything what you have named. Okay, so Uplink NAS Transport basically gives you, for example, if you check the payload container type over here, okay, it has the information. For example, the bits can be from 4321. This is the binary value, and you can see that if the N1 SM information, if it's 1, then it's N1 SM information, and if you see that over here, the payload container type, NOI payload type, which is 14 over here. So you can based on the payload container type, that what you are having, you can you can have the value over here, if it's, and the contents basically is FFFF, which is the encrypted form. So this is what you cannot see it. Okay, basically, so this is the payload type what you are seeing over here. Okay, so the next message is basically the PDU session ID. So in the PDU session identity value, there can be numerous identity values. Basically, you identify the PDU session from the PDU session ID. So if it's like an initial request or if it's a follow-up request, or what PDU session is there, you can and you can also be helpful in doing the one when you are doing the charging, to see that which PDU session is this. So this is, so since this is the initial request, so it is 1 over here, and also you can see that you can keep so basically you can configure it's actually by default in the node that you will see all these values, which you cannot actually program. You can just once the PDU session is changed, you will see this values changed, as far as I know. Okay, the Uplink NAS Transport, which is the same message over here, Uplink NAS Transport, that we are actually deciphering. So the uplink NAS transport have, for example, this value, the initial request, it is having the one value. So it is telling you basically over here that the request type is initial request. If the PDU session establishment procedure is a request to establish a PDU session, so it will be one. If it's existing PDU session, then if the request to refers to an existing PDU session switching between 3GBP and non 3GBP, then indicates emergency request, so it is having a different value. So all this you can see that this is all different values in over here, which you can see based on the uplink NAS transport or based on the request that you are having. Okay, what else we can see here? So the key parameters also to see is the S, NSSAI and the DNN over here. So if the UE carries only the DNN, the AMF determines the default S NSSAI based on the subscription information, or determine an S based on the local configuration. So if it's carrying both, then it's good. If it's only carrying the DNN, then AMF will get the default S NSSI based on the S NSSI based on local configuration, that what is allowed, what slicing instance is allowed. So remember, there is something called a configured SSNI, subscribed and allowed. So it will always check that what is allowed and put it as a default SNSSI. Okay, then if a UE carries only SNSSI, the AMF determines the default DNN and vice versa. So basically this, if it's having one, if it will retrieve the SNSSI, or if it's the UE is only carrying SNSSI, then the AMF determines the default DNN based on the subscription information, or determines the DNN based on the local configuration. So here you can also see the DNN over here, which is CMNet, or you can take anything based on your network configuration. Okay, now the PDU session establishment request, when it goes to AMF, what it has, the PDU session identity one, which is one, which is telling that which PDU session is this. Then what happens then in the PDO session establishment request, also there is also, you can have the integrity protection maximum data rate. So this is basically will tell you that what is, and this, by the way, this has all been determined in the registration procedure, that what sort of maximum integrity protection maximum data rate the network supports, which helps in the replay attacks that the UE sends, or any ROG base station sends to the AMF. The AMF knows that, okay, what is the maximum data rate over here which is being set. So if it's 64 kbps, it will not be receiving anything more than that. So we know that it is, it should be, so it should have the integrity mechanism. So basically, if it's above than this, then it will result in the failure. So maximum data rate per UE for the Userplane integrity protection for uplink and downlink, this has already been set in the registration procedure, which is 64 kbps over here. It is the full data rate. Okay. Now what happens? So you can see the same thing over here. The PDU session establishment request for the maximum integrity protection maximum data rate is uplink and downlink both 64 kbps, which is being set. Okay. This is telling you what the PDU session type, if it's IPv4 or IPv6. So you can also see this in the payload or trace type over here. Yeah. Now this is important over here. So for example, the key parameters, the SSC mode, you know that in the 5G we have three SSC modes. One is telling you, for example, if you need to keep the same IP address to the UE should not be allocated a different IP address for the PDU session. One PDU session can have one IP address. For the SSC mode 2, it will, for example, it will allocate a different IP address to the UE. And in the third one, basically, it will first, so the difference between SSC mode 2 and 3 is basically in the mode 3, the IP address for the new UPF, for example, is first established, then the previous session or the user plane with the previous UPF is released. Okay, but what happens in the SSC mode 2, first is released, the IP address is released, then it is established. So it is actually the vice versa procedure in SSC mode 2 and 3. But basically what it is telling, that the UE in certain applications, if it's, for example, which requires low latency. So the UPF can be changed based on where the UE is moving, and then the IP address is make or break procedure can happen based on how you have configured your settings from your SMF to UPF. And SMF will actually, based on the SSC mode, basically SMF will allocate the UPF to the UE. And so you can, if you want to read more, you can actually search on the internet and go to the call flows of all these SSC mode values. So basically in this this SSC mode 1 would be coming from the UE itself. Okay, that this is what the request is coming to. Okay. Then there is also a thing called 5G SM capability, whether the reflective queue is supported, not supported, whether the multi-home IP session not supported, supported. So this is what basically. So in this case, basically the reflective QoS is supported. So reflective QoS, if you don't know what is reflective QoS, reflective quality of service is also being a new concept in 5G, which tells basically that which actually the network tells the UE that this is the quality of service we support, and this will tell the UE on the downlink message. And then for that thing, once the UE will get that, okay, this is what the network supports, the quality of service, then it will send the same quality of service on the uplink. So this is due to the reflective quality of service introduction in 5G. This is what is been there for. Okay, which is actually basically you can have such a modification procedure, but this is the new concept in which the UE can adapt based on the network or quality of service. Okay, moving forward, PDU session establishment request. It is you can have always on PDU session requested. You can have this value 1. So this is basically the same thing that we know. Okay. What else? Information extended protocol configuration options, blah blah blah. This is all we have covered. IPv4 SSC mode 1 reflective QoS supported. Extended protocol configuration option. This is I mean something if we are changing the protocol or we are appending some information into the payload. This is where you can configure it, but this is not mainly used. And yeah, so this is, I think we can ignore this thing. Okay. Now, when it comes to SMF selection, what are the parameters that the AMF knows in order to select SMF? Basically, if it's a new session, the AMF selects a proper SMF for it. With proper SMF, it means that AMF has to either, because AMF doesn't have the SMF information. So either it has to go to NRF to know which SMF the request needs to send to, or AMF has to be configured that based on the DNN you have to route to this SMF, based on the SNSSAI you have to route to this SMF, based on the RAT type. So it can be different procedures based on your token network configuration. Basically, if the request indicates existing PDU session, like the if it's like having a same existing PDU session, the AMF selects an SMF based on the SMF ID and SMF mappings obtained from the HSS plus UDM in the initial PDU session. So this is so basically AMF will be already having the information that which SMF it needs to send the request to, basically. So yeah. So then if you see over here, the SMF selection subscription data, SUPI, SNSSAI, subscribe DNN list, default DNN, local breakout, roaming information, interworking with EPS indication list. This is what is the selection subscription data. So based on, for example, this is, you can think of as the NFP profile that you send to the NRF. So if you have, for example, the SUPI, you need to have the SMF selected based on the SUPI type. You can do this for the subscribed DNN list. You can see that list of the subscribed DNN for this UE default DNN. If the UE does not provide a DNN, local breakout indicates whether the local breakout roaming is allowed per DNN or not, or per NSSAI. So this is all what is the selection criteria of the SMF. Okay, this is what AMF basically checks, that which SMF it needs to send the request to, basically. Yeah. So for intersystem continuity context, you can see this. If you need to change your for example, AMF to AMF or SMF to SMF, you can have the inter-system continuity context. So SMF, if it needs to talk to another SMF, it will give the profile to the user, or you have to have this field thing set up. For each DNN indicates a P gateway C plus SMF which supports interworking with EPC. Yeah, so this is, you can see in the payload also if this field has been configured, which means that the interworking is there. Okay. Now SMF selection, non-roaming, roaming will local breakout in a normal criteria. When you are not roaming and when you are going to the internet from your network, what you do, the AMF goes to NSSF to check that which slicing thing, if it's a default slice or a slice that give me the slicing profile of the user basically. So when it send the request to NSSF, it will get the response, the NSS, the slicing information. Then it knows that okay, which SMF support that slice it needs to send the request to. So basically it will tell NRF that okay, this is the slicing profile of the user, this is the SUP information, this is the DNN, so give me the which SMF I need to send, I need to send the request to. So then it will send the request and it will get the response over here from NRF. So this is basically, then the AMF will go to SMF over here. Here's example of SMF, the same procedure. The SMF, the AMF will go to NSSF first, then will go to NRF. Then the NRF from here will select that which SMF it needs to send the request. Or which SMF profile I need to send to the AMF. So this is how, this is one of the examples that you can see over here. NRF discovery request. This is the NRF discovery request that we have seen over here, that we can see that how you can send the request to basically SD is the slicing ID, the bit flag, the DNN type, everything is there. So this request is sent from AMF to NRF. Okay. Then what happens over here? You see, yeah. So the NF discovery request response, what is being sent from an NRF is basically all the NF instance ID, version, URI, logic link, IP address, URI, IP address. This is all information. So basically this is the, if you see over FQDN. FQDN is the SMF ID or the address that the NRF gives in the response of this request. Okay, this is what AMF is been looking for actually. Yeah. So if you see for the roaming scenarios, I will not go into the details of the roaming. We can cover the session management when we will discuss the roaming. We can cover that part over there. Okay, but basically over here you can see VP element and the home P element. So if the AMF, so if there is a local breakout which is false, then you have to go to home routing roaming, in which you can have to select everything to the home network for the request to. For example, then AMF will send the request to VNSSF, VNSSF will send to the HNSSF. Then, so the same procedure happens, but it will be different V or the home NSSF and the home NRF that will, because we need to select the home SMF actually over here. So if it's AMF, visitor AMF, the AMF will select the home SMF in terms in case of home routing. Okay, yeah, this is the important thing you need to get. Option 2, this is we can cover, I think, talk in more details in some next slide. Okay, so when the PDU session create SM request goes, what happens over here? The AMF sends a PDU session create SM context request message to the SMF over here, requesting the SMF to create a session context. You need to have a session context over here. So the AMF sends a request to SMF, the request message, which has basically the SUP information, PE, which is the IME information, Gypsy, session ID, DNN, all this information you can see in the create request message context, SM context, create request to SMF. Initial request is what all we have covered initially. Continued the existing, the PDU session request, the RAT type, new radio tie value, which is the cell ID information of the user, NCGCI profile, the time zone, SM context, status URI, that in which the AMF needs to be notified about the thing if there is a change in information or the status information, EPS networking indicated or not, shell mode verified. So DNN, what is saying, DNN selection mode indicating whether the subscribed DNN or the wildcard DNN is displayed for the requested DNN. The value can be UE, DNN not verified, or network DNN not verified. Other values with N26 or without N26, if it you need to connect with the EPC network and you're having like say the 5G non-standalone, you need to have the EPC fallback also. It's been there. You can search see from this request. Okay. Then the ECM registration, SDM get and SDM subscribe procedure. This is what basically the SMF will asking or taking the profile from the UDM. This is what happens in the ECM registration procedure basically. So it will notify UDM about the new things that it has been receiving from the AMF based on the session to update on the UM, and they also take the SM profile of the user that what is there. So in the registration procedure, the SMF instance ID, P gateway, PGWF UDN, this is what is been there. So it is basically updating the UDM on its profile. A response, what happens on a registration success, the UDM returns a response body that contains created SMF registration source. So once it's created, it will send the response to the user, which is all these fields you can see over here. Then the SDM get message that will be sent from SMF after the ECM registration procedure. The SDM get message goes to the UDM. It has have all the IMSI profile of the user, SSD, the slicing type, the ID, the DNN, all information is there. Then based on this, the UDM will send the profile to the user that what they have configured based on this SUPI and this slicing ID. It has a profile SM data, because once you provision the user, you create the SM data profile, AM data and SM data profile in the UDM. So this is what you basically are retrieving from UDM in this SDM message. SDM get response here. If there is a local breakout parameter which is false, it means that you have to send to the home routing, home network. You cannot go to your network. You cannot go to the internet from your network. So this is one of the important parameters also, in which you determine that whether the local breakout is enabled or not. Here you can see the different SSC modes. This is by default. This is the allowed SSC mode. To mode 3. This is the DNN value. So this is what is being downloaded into SMF. Okay, moving forward, what else we can see here? Yeah, so this is the NGS QSTPL. Also you can have the response. So basically this is the AMBR, the aggregated maximum bit rate, uplink aggregated maximum bit rate, downlink 11 Gbps allowed. This is all what you are receiving in the SMF profile. Yeah, so basically this is the default you can think of as the QCI, default QCI that is being, or the NGC, quality of service template. You can also configure the AMBR maximum and the downlink maximum over here. And then once the SMF will receive the GBR, the QCI profiles from the PCF, it will if it's, for example, exceeding this value, it will not, it cannot exceed this value. This is the maximum allowed thing, so the values for the PCRF, the QCA values, needs to be under this what is being allowed. Okay. The SDM subscribe over here, then the SMF will send the SDM subscribe message, which contains the SMF instance ID. When the SMF registered from the UDM, the SMF relevant subscription will become invalid. This is what is being telling over here in this implicit unsubscribe true message. The URI provided by the SMF used for UDM to send notifications. This is how the UDM will send the notification to SMF. Then there is also resource identified by URIs on the UDM. If a resource changes, the UDM is triggered to send a notification. So this is what is being done, guys. I know it's a lot of information, but this is what needs what he will give you exact clarity of your concept. And in your interviews also, if somebody will ask you, you know that what parameters you can see in each of these requests. Okay. What happens then, once the SMF will get the profile from the UDM, it will send the response message, create SM context, and hey, I have created the context which is being initially asked for to response to the AMF over here. You can see this response message. Created HTTP to created location, all this information, SM context value you can see over here, which has been created. Okay. Now what happens, the PDU session authorization authentication flow, which I have told you that if the UE provides the DN relevant authentication authorization information in a PDU session, or the SMF determines the PDU session needs to be authenticated and based on the local policy associated with the DN. So in the UE message, if the session the PDU message which goes to the SMF, if the DNN doesn't have the local policy, it will simply reject the request, because the user plane policy needs to be coming from the UE in the DN. Okay, to give the DN, and once the SMF receive this, then it will check the policy from the UDM, what's been configured as a policy, then it will send the authentication authorization message, but then the UE needs to be authenticated. However, if the SMF determines to authenticate a PDU session but the UE does not provide, the SMF rejects the session establishment request. So if it's there, good, what is the policy configured in the UDM for the UE, then it will go or do send a message to the UE to authenticate itself from a AAA server or for any authentication server. Okay, if the policy is not coming, then it will simply reject the session establishment request. This is also what is being. So this is important to know, that for every PDU session there is an authentication authorization happened. If it's already been done, if it's existing PDU session, then it will not do for the second or the third time, but it will do for the first PDU session. And you can maybe change it in some networks, in some vendors, you can maybe change that, how many times you need to do this PDU session. It will actually help you in your integration to checks, and the session checks that whether your session is not hijacked, or once the registration is done. So it's an added layer of security which happens over here. Okay, so this is the procedure about on the PDO session establishment authentication authorization procedure from the DNN. I'll not go into the details of this one. It is basically just taking the message from the UE, from the NAS layer, sending the message from the NAS layer, from SMF, and then authentication is being done from the DNN based on the authentication policy you can set up in your AAA server. Yeah. EBI message, EBI Assignment Request message that the AMF sends to AMF, that okay, SMF allocation for EBI D for AMF is supported or not. Basically, this is what the message goes to SMF to AMF. Okay, which tells basically the PDU Session ID, ARP list, priority level, what is the policy, or the ID related things is being sent, so the AMF know that okay, what is the priority level, because it will help you to in terms of congestion or something, for the area, which areas, which UE for which the session needs to be created or should not be released. Okay, so this is what SMF tells the AMF, which having the ARP, the retention policy, retention, in which in terms of the congestion in the network. Excuse me. Okay, so then the EBI assignment response back to the SMF that the bearer is the EPS bearer ID established on this bearer. So this is actually the this is the or quality of service flows, in which the SMF will tells the AMF that what is being allowed in the network. Okay, yeah, and the AMF will respond by creating a bearer ID for that request, that okay, this is the bearer which has been having all these values basically. Yeah. Okay, then the enforced establishment procedure happens from SMF to UPF, in which the the request sends to the UPF, in which you can see that SMF instructs the UPF to remove the specified outer header from the package that meets the PDI. What is the forward indicator values, what is the destination interface, core value, instruct the UPF to assign a TID, tunnel ID, and IPv4 address. So this is for, in some cases, if you're having a static IP to the user, the SMF will gives the IP to the UPF to allocate to the UE, or in some cases, and then it has to have a pool mapping with a tag, and the public, the private IPs, the mapping needs to be there in the UPF if it needs to allocate the IP, and it has to have a corresponding VRF based on that. So this is how you establish the user plane for the user. Okay, then what happens, the PDU, the request also also contains, so here if you see over here, UE IP address assignment attribute, UPF first, this is what you can see in the address attribute, and then instruct the UPF to assign IPv4 address. This is you see over here the bidirectional SDF filter over here, destination interface. So all this parameter that is being sent the request, the SMF send the request to UPF. Yeah, there is also a GTBC thing which I will tell you. So PDFCP session establishment request also contains the QoS flow identifier, value, one, maximum bitrate, what is being allowed, what is maximum bitrate. This is what is being, what it is getting from, for example, if you see above, we have seen the SDSM data profile that has been downloaded, which has the QCI value, or sorry, the quality of service value, a 1 GBP. So this is what SMF will tells the UPF that this is what is being allowed, so that should not overload or can go beyond it. This is the MBR maximum bitrate uplink downlink. This is what you can see over here. PFCP submission request also contains IPv4 user plane inactivity timer, what is instructs the UPF to report the timeout period of the user plane inactivity timer. If the user plane is not being activated, then it will release the to user plane based on this timer. Yeah. Then what happens after that? Yeah. So this is the also one of the message is the GGSN IP IPv4 address, P gateway, C, S5, S8 IP address. This is also being allocated. So basically, it is actually establishing the GTBC tunnel over here, which is giving you the IP address that what is the tunnel IP address in which the UPF can talk to SMF. And this is the VRF corresponding VRF. This is all the description of that thing. Yeah. Response, then the PFCP establishment response procedure. The UPF will respond with the tunnel ID, the IPv4 address of the user. Then there is an IPv4 address over here, which you see over here. With okay, this IP is the tunnel IP address. Okay, and this IP is what IP address is being allocated to the UE. Okay, UE IP address, which you can see this field over here. So don't get confused with this IP address and this IP address. This is the tunnel IP address, and this is the IP address of the UE. Okay. Then what happens? Then the SMF needs to send the IP address to the UE. It will send the N1 and N2 message transfer request to the AMF to send to the UE, which has all the message. Basically, this will be the NAS message that will be sent to the UE. The AMF will respond transfer response message, HTTP OK, transfer initiated. This is then it will send the message to the UE. Then you can see that the AMF will send to the UE the message which has the PDU session NAS PDU identifier. Then the request transfer, the aggregated, the UE aggregated maximum bitrate downlink, what uplink downlink it needs to keep. Over here, if you see this request, yeah, the used to calculate UE MBR, UE UPF N3 interface IP address and GTP to GTP U tunnel ID point. So this is important because if you see that if the user has to go to the internet, the N3 interface from UPF towards the RAN and from UPF to internet, the N6 interface needs to be established. So the whole the GTP U tunnel has to have the tunnel IDs and the IP address in which the user can send the quality of service profile or the bearer, to the internet. So it has to have the GTP tunnel ID and needs to have the IP address of yeah. So the air interface, user plane integrity protection, encryption, integration. This is all what also mean there that what is the confidential. This is used to encrypt the traffic of the user. Yeah. Integrity protection is basically the maximum bitrate or the thing that we have seen earlier. This is what the user know that this is what they can reach to. Okay, what the packet value should be like. Okay, so this is the priority level ARP values, allocation and retention priority, in which the will tell the AMF that okay, this is what is being configured. So it should be checking that if there's any congestion or not. So it should to discard the packet or should keep the packets. Yeah. Okay. Accept message, then the UE will the PDU session establishment accept message. It will the AMF will send to the UE, which has the payload container contents FFFF the PDU session ID. Then what happens? It will accept message will also contains that which uplink and downlink value you need to keep it. What is the QoS rule? is the default QoS rule, or is there any rule which has been dynamic or configured in the PCRF, which has been also sent over here. You can see the PDO Session Identity one, the SSC mode, which has been supported, PDU session, QoS flow identifier one, other values downlink only bidirectional. So this is 0 indicates no QFI. Okay, so this is 0 indicates if it's no QFI over here, so if it's QFI something over here, equality of flow or indicator, it has to have some value over here, so this is if it's been what is being configured in the PCR basically. Yeah. What happens next, then you can see the MBR values over here, slicing type, ID. So this is, I think, too much details, which is not all thing relevant. PDU session accept, here the QoS flow identifier here would be the one value. You can see that what you can see different values over here. 5QI one is value which is important in context of 5G. For APS identity, which is 7 over here, and this is the value that is the for the DRAM which has been there. So I think this is all what we need to know. Yeah, the PDU session request setup response, the Gnode N3 interface IP address, the GTPU tunnel endpoint ID, which is needs to send to AMF to establish the N3 tunnel. Okay, and it needs to establish to have this information. So this is the same information that we discussed earlier as well. What happens this then the SMF, then the AMF will send the update SM context request to the SMF over here, which is having the response when you accept the message, everything is done, the tunnel information is shared. Then the AMF will tell SMF that okay, hey, everything is done and we are good to establish the session over here. Then the modification, the VRF settings will be sent to the UPF that okay, you need to establish the request to establish the N6 interface and 3 interface on this VRF access point. This is the VRF access you need to get the request from N3. Okay, Gnode N3 interface IP address, GTPU tunnel endpoint ID, which is all you can see over here, which has been there. Yeah, so this is request accepted, sent to the UPF, sent by the UPF to SMF based on that request. So this is guys, this is all about session establishment procedure. As a summary, what you need to remember, going forward to your interviews or to your configuration settings. That's the first step. AMF receive PDU session establishment request from the UE. Okay, the AMF select SMF and forward the PDU session establishment request to the SMF based on the criteria that we have discussed earlier. Should be NRF, NSSF based on. Then the AMF interact with the UDM to obtain SM subscription data. The SMF interacts with the DNN server for secondary authentication based on the user DNN policy. The SMM interact with the PCF to obtain the SMM policy, that what QCA values it is configured, what is the dynamic rule, or is there any rule configured for the UE. The UPF is selected, N3 user plane connection established by establishing the N3 tunnel ID identified to the user, giving the IP address. Then from 11 to 14, basically user plane connection over the interface established. This blah. I think it's all. I'm already exhausted. So I hope that you have enjoyed this session, and please give me your feedback. How did you think about this session? What are your comments? If I have speed, if I have or have something or delivered a quick or have gone through quickly in some slides, also please provide your feedback, and I hope to see you in the next session and give you more details about on roaming and 5G security. Okay, thank you very much and see you soon.